and sugar. Some of these foods taste sour, some taste bitter, some taste sweet, and some are salty. The sour, bitter, sweet, and salty taste of foods arises due to the presence of acids, bases, and salts in them. In the 17th century, chemist Robert Boyle first labeled substances as acids and bases. In this lesson, you will study about the properties of acids, bases, and salts. Objectives. At the end of this lesson, you will be able to define acids, bases, and salts. List the properties of acids and bases. Many of us like sour taste of food. You must have noticed that sometimes juices we sip are sour in taste. Generally, sour-tasting substances contain acids. Some fruits contain citric acid, which is sour in taste. The origin of the word acid is the Latin word acer, which means sour. Acid is found in natural substances like fruits and vegetables. Have you heard that sting of an ant or a bee contains acid and causes the burning sensation? Different food items contain different acids. Citrus fruits like orange, grapes, mandarin, lemon, etc. contain citric acid. Vinegar found in our kitchen is dilute acetic acid. Ascorbic acid is found in guava, orange, raspberries, etc. Malic acid is found in many fruits. Apple has quite rich in absorbic acid. Most of the children love more cheese in pizza. Cheese and curd contain lactic acid. We wash our clothes every day with soap. Do you know which kind of solution it is? Soap solution tastes bitter, and on rubbing on the palm, it gives a slippery feeling because it contains base. Thus, those substances whose aqueous solutions have a bitter taste and a slippery feel are called bases. Water-soluble bases are known as alkali. The word alkali is derived from the Arabic word alkali, meaning ashes, referring to the original source of alkaline substance. Students, the chemical name of lime is calcium hydroxide. Lime water is prepared by dissolving lime in water. Milk of magnesia is a medicine which helps us in digesting our food. It contains magnesium hydroxide, which is a base. The baking soda used in making cake, breads, and in other bakery items contains sodium hydrogen carbonate. When your mother cleans the window, put a drop of solution she is using on your palm and feel it. You will feel slippery on your palm. This is because cleaners are made of ammonium hydroxide, which is a base. We use chalk in schools for writing on the blackboard. Is it a base or an acid? Chalk gives a basic solution when dissolved in water. It is called calcium carbonate chemically. Match the following. Tick on the options in the column A and then click on the related options given in the column B. Do you know you feel relieved on applying baking soda on ant sting? This is because baking soda neutralizes the acid present in ant sting. Now that we know what an acid and a base is, let us find what happens when an acid is mixed with a base. An acid and a base combine to give salt and water. Let's do the following experiment. Add some phenolphthalein to dilute hydrochloric acid. The indicator remains colorless in the acidic solution. Now we add a solution of sodium hydroxide in the small portions. At a certain point, the indicator changes color, which means that the acid completely neutralized by the sodium hydroxide and some excess hydroxide ions are present in the solution. Reaction produced to salt, sodium chloride, and water. The reaction of acids and bases is also known as neutralization reaction. Sometimes we feel inflammation in our stomach. Why is it so? Our stomach secretes hydrochloric acid, HCl, a very strong acid which helps us to digest food. But too much secretion of acid in the stomach causes inflammation. To relieve the sensation of inflammation, an antacid is taken. Antacid contains base that neutralizes the excess acid in stomach. Soils which we use for cultivation can become acidic or basic in nature. The basic soils are treated with organic compounds which release acid. Thus, the soil becomes neutral. Many factories release the acidic wastes which, after falling in the water bodies, damage them. As a result, living organisms of water die. The acidic wastes are neutralized with the bases like slaked lime before their disposal. Drag and drop the correct option in the blanks. Summary. Let us summarize what we have learned. An acid is defined as a substance whose aqueous solution is characterized by a sour taste. A base is a substance whose aqueous solution has bitter taste and a slippery feel. A salt is formed when a base reacts with an acid. The reaction between an acid and a base is known as neutralization. Neutralization plays an important role in our everyday life.
In this lesson, we'll be studying the neutralization reaction, focusing on the chemistry of alkalis. Remember that an alkali is not exactly the same thing as a base. All alkalis are bases, but not all bases are alkalis. A base in aqueous solution is slippery to the touch, has a bitter taste, has a pH of above 7 and reacts with acids to form salts. An alkali has all of these qualities and some other more specific ones. It is an ionic compound dissolved in aqueous solution. It is always made using the positively charged cations of either an alkali metal from group 1 of the periodic table or an alkali earth metal from group 2. For the examples we're going to look at, the negatively charged anion will always be hydroxide, OH-. Some authors have a simpler and more general definition that an alkali is simply a base which dissolves in water. Imagine a beaker containing water and some sodium hydroxide. Now when a base dissolves in water, its cations and anions dissociate, that is, they're free to move about in the solution. The concentration of hydroxide ions in the solution is one way of telling how basic that solution is. So the higher the concentration of OH-, the higher the pH. Now imagine a second beaker, this one containing some hydrochloric acid. You might know from previous lessons that when a strong acid dissolves in water, its H+ cation and negative anion dissociate in a very similar way. So if we slowly add the acid to the alkali, all we're doing is creating an environment where the positive H+ ions can get together with the negative OH- ions and create neutral water molecules. As this happens, the number of free OH- ions in the first beaker decreases, and so too will its pH until it hits 7 and the solution is neutral, although there will still be tiny amounts of H+ and OH- ions present in equilibrium. So here's the equation in full. If we were to continue adding acid past the neutralization point, there will be an excess of H+ ions and, you guessed it, the pH would drop below 7. So what are the uses of doing this? When we have solutions of chemicals in the lab, it's often really important to know their molarity as precisely as possible. So say we had some old sodium hydroxide solution that we knew was about 0.2 molar. We could get a much more precise figure than this by titrating it with some hydrochloric acid that we do already know the precise molarity of. Here's a video all about titration if you've not heard of that term before. All we need is a way of accurately monitoring the pH and a very handy little equation. Now what this means is that at the point of neutralization, the molarity of the acid times by the volume used equals the molarity of the base times its volume. If we know 3 out of the 4 terms, we can work out the fourth by some simple rearrangement. So here's your challenge. You've measured out 20.00 cubic centimeters of our mystery sodium hydroxide into a beaker. That's Vb. Our hydrochloric acid was 0.1937 molar. That's Ma. And to make our solution completely neutral required a titration of 22.26 cubic centimeters of the acid. That's Va. Can you work out Mb? Pause the video and have a go. Here's how you rearrange the equation to find Mb. And now we just pop all our values in. So the precise molarity of our sodium hydroxide is revealed to be 0.2156 molar. How did you do? There are other times when neutralizing a base can prove very useful. For example, factories that produce clothes dyes create a very strongly alkaline aqueous waste with a pH of between 10 and 12. By law, they aren't allowed to release this into local rivers, but if they neutralize their wastewater, it becomes much less harmful to the environment and they won't get into any legal trouble.
Neutralization in everyday life.
We'll be studying the neutralization reaction, focusing on the chemistry of alkalis. Remember that an
You probably heard of the terms acids and bases, right? But
Subscribe the channel and press the bell icon to get latest updates from learnfatafat.com.
The reaction of acid and base so as to neutralize each other's effect, producing salt and water, is called neutralization.
Watch ad-free and complete syllabus on Learn Fatafat Android app. Download the app now.
Knowingly or unknowingly, there are many neutralization reactions happening in our daily life. Let's understand some of them. Tooth decay. Microorganisms act on food particles in our mouth, due to which there is formation of acid. It acts on tooth and thus results in tooth decay. Toothpaste is used to neutralize the effect of acid and thus preventing the tooth decay. Indigestion. When we eat food, it goes in stomach. Here, the hydrochloric acid produced in stomach acts on food to digest it. However, sometimes our body does not digest the food and we feel fullness in our stomach or burning sensation in upper stomach area above it. It causes pain. This condition is called indigestion. It happens due to excess of acid in the stomach. To relieve indigestion, we take medicine consisting of base such as magnesium hydroxide, which is also called milk of magnesia. It neutralizes the effect of acid and thus we feel better.
Watch ad-free and complete syllabus on Learn Fatafat Android app. Download the app now.
Ant bite. Ant bite is very painful because during the bite, ant injects an acid called formic acid in our body. It causes burning sensation and pain. If you make mixture of baking soda, that is sodium hydrogen carbonate with water, and apply it on the bitten area, we feel relieved. It is because the base, that is baking soda, neutralizes the formic acid. Soil treatment. Fertilizers are helpful for crop. However, excessive fertilizers causes soil to become more acidic or more basic. Such soil is not suitable for crop growth. In such case, we use neutralization reaction. Acidic soil can be neutralized by spreading base such as quicklime, that is calcium oxide, or slakelime, that is calcium hydroxide. And if the soil is basic, then organic matter such as animal and plant waste is added to soil. It produces acid and thus neutralizes the effect of base in soil. Factory waste. Many times, factories release wastewater in water bodies such as river and pond. The wastewater contains various acids, due to which water becomes acidic. Such water is not suitable for aquatic organisms, that is, organisms living in water. Therefore, it causes their death.
Watch ad-free and complete syllabus on Learn Fatafat Android app. Download the app now.
To avoid this, bases are added in wastewater so as to neutralize the effect of acids. Here also, neutralization is useful. Thanks for watching this video.
Like, share and subscribe learnfatafat.com and press the bell icon to never miss an updates from learnfatafat.com.
In today's video, we're going to look at the pH scale and see what acids and alkalis are. pH is really just a measure of how acidic or alkaline a solution is, and it's measured on a scale from 0 to 14, with low numbers being most acidic and high numbers being most alkaline. And if the substance is neutral, like pure water, then the pH would be 7, which is neither acidic nor alkaline. To give you some idea of what all of this means, the acid in your stomach, which helps you to kill bacteria, has a pH of around 2, while acid rain is around pH 4. Then for alkalis, washing up liquid has a pH of around 9, and the bleach we use to clean bathrooms has a pH of around 12. Be aware though, you don't have to remember these specific examples, they're just to give you some context. Now we can measure pH in a couple of different ways. One is to use some kind of indicator, which are a group of chemical dyes that change colour depending on the pH, and different indicators will change colour at different pHs. Some indicators contain a mixture of these different dyes though, so their colour will slowly change across a wide range of pHs. So we often refer to them as wide range indicators. The most common example is universal indicator, which gives the colours we've shown on our pH scale here, ranging from deep red at a very low and acidic pH, to yellow, green and then bluey purple as we increase the pH and it becomes more alkaline. The other way to measure pH is to use a pH probe connected to a pH meter. By dipping the probe into a solution, we can electronically measure the pH and get a numerical reading on the meter. The benefit of the probe compared to an indicator is that it can be much more accurate and precise, because it doesn't involve humans guessing shades or particular colours. And as a general rule, measurements that remove the need for human judgment are going to be more reliable. The next thing we need to look at is what exactly makes something an acid. You can define an acid as any substance that forms aqueous solutions with a pH of less than 7. And the reason for this is that acids release hydrogen ions in water, which make the solution acidic. On the other side of the scale, we have bases, which we define as any substance with a pH greater than 7. Meanwhile, alkalis, which we mentioned before, are actually a subgroup of bases that are soluble in water. So we would say that an alkali is a base that dissolves in water to form a solution with a pH greater than 7. And these alkalis form OH- ions in water, which we call hydroxide ions. If we react an acid and a base together, then we get a neutralization reaction, which will always produce a salt and water. For example, hydrochloric acid plus sodium hydroxide, which are the most common acid and base, will react to form sodium chloride, which is a salt, plus water. Another way to show these neutralization reactions is in terms of hydrogen ions and hydroxide ions, where H+ from the acid and OH- from the base combine to form H2O. And because the acid and base have both been neutralized in these sorts of reactions, the pH of the products should be 7 because they're neutral. Before we finish, I just want to point out some of the common acids and bases that you'll come across in the course. The main acids are hydrochloric acid, sulfuric acid, and nitric acid, while the common bases are generally hydroxides or carbonates, like sodium hydroxide or calcium carbonate. There are loads more, but it's definitely worth learning these few, as they crop up a lot.